Hello, everyone. As you can see, today we're going to talk about properties of real numbers. And the first property we're going to look at is called the commutative property. There's one for addition and there is one for multiplication. The commutative property says that we can add or multiply in any order. So for addition, A plus B is the exact same thing as B plus A. For multiplication, A times B is exactly the same as B times A. It doesn't matter what order we multiply in. If we have a string of multiplication, it doesn't matter what order we add in if we have a string of addition. So to help you remember that this one is the commutative property, remember commute means move. Your morning commute is where you go from one place to another. Here we're physically lifting up the A and the B and we're moving them into different locations. So let's do some examples. Let's use one of the commutative properties to complete each statement. A, we have x plus 8. The commutative property says we can move them around. It doesn't matter what order we add in. So an equivalent statement to x plus 8 using the commutative property would be 8 plus x. Likewise, when we're multiplying, here we have 7 times x. The commutative property says we can multiply in any order. We can move them around. And that gives us, x plus 7. Or sorry, x times 7. 7 times x is the same as x times 7. Okay, let's move on for real now to the associative properties. The associative properties tell us that we can group addition and multiplication in any order. We can do any grouping. For addition, if we had a plus b plus c, we can add a plus b first and then add c. Or we can move the parentheses over to the b plus c and add b plus c first and then add the a on. Likewise, the associative property of multiplication tells us that we can group a times b in a times b times c and multiply a times b first. Or we can move the parentheses over to b times c and multiply b times c first and then a. It doesn't matter which grouping we do first. To help you remember that the associative property is the grouping one, remember that associate is like grouping. The people you associate with could be the people in your group. So some examples of the associative property. Let's use an associative property to complete each of these statements. Here we're adding 3 plus 8 plus 1, and the grouping is around the 8 plus 1. The associative property tells us we can move these parentheses over to this group and group the 3 plus 8 first, and then add the 1 on last. We'll get the same answer either way. Here in B, we're multiplying negative 5 times 4 times 2, and it's showing the grouping of negative 5 times 4 first. We can move that grouping over to the 4 times 2, and instead multiply those first and then the negative 5 last. In C, we have xy times 18, keeping in mind that xy means x times y. This is another example of the associative property of multiplication. Instead of grouping the x times y first, we can group the y times 18 first, giving us the y times 18 in parentheses multiplied by the x last. So let's use the commutative and associative properties to simplify these expressions. Here we have negative 3 plus x in a grouping first, plus the 17. As a first step, to help us get eventually the numbers by each other so we can add them together, we can move the grouping from the negative 3 plus x to the x plus 17. That's the associative property. We could use the commutative property then to move the 17 and the x into different positions. And then finally, we can regroup once more using the associative property and group the negative 3 plus 17 first. Then we can add negative 3 plus 17 to get positive 14 plus x. And we can't simplify this anymore. We can't add just numbers with x things. So instead of using these properties and making all these different changes, in the end, we're just able to drop the parentheses since it's all addition, and then add the things that can be added, the negative 3 plus the 17. But it's the associative and commutative properties that are working in the background while we do that. In B, we have 4 times the grouping 5x, but this is all multiplication. The associative property says we can regroup these and group the 4 times 5 together first. 4 times 5 gives us 20, so 20 times x. Again, we can't simplify this any further because we can't multiply numbers by x things and get something else. But once again, these properties are working in the background. In practice, all we have to do is notice that it's all multiplication. We can drop the parentheses and multiply what we're able to multiply, the 4 times the 5. The next property we're going to discuss is the distributive property of multiplication over addition, better known as just the distributive property. If we have A times the sum B plus C, we can multiply the A times the B and then add the A times the C. And we're going to take a deep dive into the distributive property at the end of this video after we go through the rest of these properties. Next, we have the identity properties for addition and for multiplication. Identity means giving us back what we started with. So for addition, the identity element is 0 because we can add 0 to anything without changing it. For multiplication, the identity element would be 1 because we can multiply anything times 1 without changing it. So for addition, the identity is 0 because we can add 0 and not change. For multiplication, the identity is 1 because we can times 1 and not change. These identity elements, 0 for addition, 1 for multiplication, are at play when we talk about additive and multiplicative inverses. Remember, additive inverse just means the same as opposite, and recall that we can add opposites together and get 0. 0 was the identity element for addition. Recall that multiplicative inverses is the same as reciprocals, b and 1 over b. And recall that we can multiply reciprocals together and get 1, 1 being the identity element for multiplication. So now let's look at a bunch of different things and name the property illustrated by each of these true statements. A, we have 5 times the quantity x plus y, and we're saying it's equal to 5 times x plus 5 times y. This one is the distributive property. And again, we're going to take a deep dive into the distributive property next. In B, we have n plus 0 in parentheses plus 9, and we're saying that this is equal to n plus 9. No, this isn't the associative property just because we have parentheses around two things. But instead, the change is that we have n plus 0 equaling n. And that is an example of the identity element for addition, that we can add 0 to anything without changing it. In C, we have -5 times x times 11, and we're grouping this x times 11 together. On the other side of the equal sign, we have -5 times 11 in parentheses times x. This isn't just the associative property because we didn't just move the parentheses. If we did, we would have -5 times x in parentheses, not -5 times 11. That means first we moved these two around using the commutative property, and then we regrouped using the associative property. So this is both the commutative and associative properties of multiplication at play. 3 more of these. In D, we start with 5 plus and then in parentheses x plus y. And on the other side of the equals, we have the 5 plus x in parentheses and then plus y. Here, the only thing that changed was that we moved the parentheses from around the x plus y to around the 5 plus x. We used the associative property of addition. In E, we have -3 times its reciprocal, -1/3, and we're showing that when we multiply these reciprocals together, we get 1. That is an example of the multiplicative inverse property. Reciprocals multiplied together equal 1. And in F, we have -5 plus its opposite of 5. And when we add these opposites together, we get 0. This is showing that when we add an opposite, we get 0. That's the additive inverse property. Okay, now let's take that deep dive into the distributive property. Okay, so the distributive property, once again, tells us that A times in parentheses B plus C equals AB plus AC. And visually what's happening is that we're multiplying what's on the outside by both of the things on the inside. A times B is A times B plus A times C is A times C. How do we know this works? Well, take a look at 7 times 2 plus 4. The distributive property tells us that we can multiply 7 times 2 and add 7 times 4. That would be 14 plus 28, which gives us 42. Without the distributive property, we would add in the parentheses first, giving us 7 times 6, which is 42. And sure, this way was relatively easier. So why do we need something like this? It's because we need to be able to expand when one of these things is x. If we had instead of 2 plus 4, x plus 4, we would go 7 times x plus 7 times 4 giving us 7x plus 28. That's the only way we can get 7x plus 28 because we can't add x plus 4 together. We can't add number things with x things. So this gives us a way to expand out things like this that we wouldn't necessarily otherwise be able to do anything with. We can extend the distributive property to any number of things inside the parentheses. So if we had 3 things in the parentheses like this, it's 3 times the first, plus 3 times the second, plus 3 times the third. 3x plus 3y plus 3z. It also doesn't have to be plus on the inside. It could be minus. And when we distribute with a minus, we have to be careful of our signs. 2 times x is 2x. And this isn't just 2 times y. This is 2 times negative y. Positive times negative is negative 2y. And we still have to be careful if there's a negative on the outside as well. Let's say we had negative 5 times and then in parentheses, negative 3 plus 2z. It's the negative 5 times both of these things. But we're being careful. Negative 5 times negative 3, negative times negative is positive 15. Negative 5 times positive 2z, negative times positive is negative 10z. So let's do some more work with these. There'll be ones at the end that I explicitly want you to try, but if you want to start pausing and trying in advance, you're more than welcome to. Let's take a look at 5 times the quantity x plus 3y minus z. It's the 5 times each of these 3 things. Positive 5 times positive x gives us positive 5x. Positive 5 times positive 3y gives us positive 15y. Positive 5 times negative z. Positive times negative is negative 5z. Next, let's look at distributing a negative 1 through 3 plus x minus w. Multiplying each of these by negative 1 is going to give us the opposite. Negative 1 times positive 3 would be negative 3. Negative 1 times positive x would be negative x. Sorry about that. Negative 1 times negative w is positive W. Distributing a -1 through is exactly the same as just distributing a negative. Distributing a negative means multiplying by -1. -1 times +2 is -2. -1 times -y is +y. So just because we don't see a 1 here, minus right up against parentheses is the same as multiplying by -1. What if we had this? Well, this doesn't look like the distributive property anymore. But remember, we can multiply in any order using the commutative property, which means this is exactly the same as the -2 first times x plus y. And then we can distribute the -2. -2 times x is -2x. -2 times positive y, -2y. Okay, now things are changing. We have a fraction in there, first of all. But notice it's not 1/2 times all of this. The parentheses end here. Where the parentheses end, so ends the distributive property. We would not multiply the 1/2 by the 10. The 10 is not involved in the distribution. 1/2 times 6 is 3, so 1/2 times 6x is 3x. 1/2 times +14 is +7. Don't forget we have this plus 10. So 3x plus 17. We can add the 7 plus 10, but we can't add that to the 3x and get something different. There might be some problems where you have to write it in reverse using the distributive property. What does that look like? Let's say for starters, we were given 8 times 2 plus 8x. 8 times 2 plus 8 times x. Well, we would notice that both of these terms have multiplication by 8. So the 8 is what would be on the outside of the parentheses. And then we kind of just think about the distributive property in reverse. 8 times what is 8 times 2? 2. 8 times what is positive 8 times x? Positive x. We've used the distributive property in reverse to write an equivalent statement. (7s minus 7t). Both of these have times 7. So the 7 is what would be on the outside of the parentheses. 7 times what is 7s? 7 times s. 7 times what is negative 7t? 7 times negative t. We've gone in reverse. Okay, let's go through examples. This time I want you to pause and try. Here's the first 3. I'm going to get started on that. We multiply the 5 times the s, and then 5 times negative t is negative 5t. In the second one, negative 6 times positive 4 is negative 24. Negative 6 times positive 2x is negative 12x. In the third, positive 2 times positive 3x is positive 6x. Positive 2 times negative 4y, positive times negative is negative 2 times 4y, negative 8y. 2 times negative z, positive times negative is negative, 2 times z is 2z. A few more. Okay, give these a try. Here we go. The negative 1 coming after the 3 minus y is the same as having the negative 1 before the 3 minus y. Negative 1 times positive 3 is negative 3. Negative 1 times negative y, negative times negative is positive. 1 times y is just y, because anything times 1 is itself. Multiplying a negative through, distributing a negative, that's the same as multiplying by negative 1. Negative 1 times x is negative x. Negative 1 times negative 7 is positive 7. Negative 1 times positive 2s is negative 2s. And now here, the parentheses don't go all the way through. So we're just distributing to the first two terms. That plus 9 gets left alone. 1/2 times 2x is just 1x. 1/2 times positive 4 is positive 2. Then we have that plus 9. And we can add positive 2 plus 9, get plus 11. So x plus 11. To finish up, try these two in reverse order. There's the first. There's the second. I'm going to get started on these. Here, both of these are multiplied by 5. So a 5 is what's on the outside. 5 times w. 5 times positive 3. Here, both of these have times 9, so 9 on the outside. 9 times w. 9 times positive z. Okay. So these are properties of real numbers.